Alright guys, we're going to do section 7-6. Go ahead and try this warm-up. When you are done with it, watch me go through it with you. So put me on pause at this point. If you look at the problem, it says when 4x squared plus 7x minus 5 is subtracted from 9x squared, so you have to start off with 9x squared minus 2x plus 3, and you have to subtract this whole trinomial, which is 4x squared plus 7x minus 5 from it, which really means that you have to distribute that negative one all the way through. The biggest mistake kids have with this problem is because we learn to read from left to right, we write down the first trinomial and then we put minus the second one. But if you read these words carefully, it's the other way around. So we have 9x squared minus 2x plus 3. Distributing through your negative 1 is going to change all the signs inside those brackets. Combine your like terms. You have 9x squared minus 4x squared is 5x squared. Negative 2x and negative 7x is negative 9x. And 3 plus 5 is 8. So the answer is, let me change my color here, 5x squared minus 9x plus 8 is right here. Okay, so we're going to do 7-6, exponential functions. 7-6 and 7-8, or 7-6 and 7-7 are actually Algebra 1 honors level. The regular algebra class does not have to do these two sections. So this is a little bit outside of the regular algebra. Exponential function is a function of the form. If you look at this, it is y is equal to a times b to the x, where a is not equal to 0 and b has to be greater than 0. B is not equal to 1 and x is a real number. All in all, what you have to understand is an exponential function really means that the variable, which is your x right here, is actually in the exponent's position, exponential. That's where they're getting that from. If you look at the two examples, for example, if you did y is equal 2 to the x and we were to build, say, a table, which we're not going to do for this one, we're going to do for another one, and you were to put in a bunch of numbers like we typically do for any type of equation and substitute them in to find what x or y comes out to, and you plotted those points, you would end up having a graph that curved like this. If you put a negative in front of the 2, like this one, it actually takes the y equals 2 to the x graph and it reflects it over the x-axis, and it would look like this. You don't really have to memorize that. That's something as you go through high school math and if you end up into the college level. These are things that you will be able to observe and notice and not always have to build tables to figure it out. One of the things that this section in the textbook doesn't actually talk about, but if your curve actually starts to go closer and closer and closer, which you could figure out by building your table, you'd have to go farther this way in the negative direction. But you would find out that your y values, as the x's go smaller, the y values get closer and closer to 0, but never touch 0, so it never actually intersects the x-axis. That is actually called an asymptote. Can't say it, but I can spell it. That's an asymptote. An asymptote is simply a curve that actually reaches a line, not necessarily the x-axis, any line, that actually gets closer to it and closer to it, but never actually touches it. It's actually a hard concept to understand. If we build a table and look at it, you would actually see it better. That's just extra information for you. If you take the leading coefficient like this 2 and you turn it into a number smaller, then you will notice that it's less than, it is less than 1, therefore look what happens to the graph. It goes in the opposite direction. If you put a negative, it reflects it over the x-axis again. So how do you know when a function is exponential? Well, if you're looking at a table, you're going to multiply to get from one value to the next. Now obviously your x's are just going up by 1s, but if you look down here, this area, You will notice to get from -1 to -3, you multiply by 3. Then you multiply that by 3 and it gives you -9. You multiply that by 3 and it gives you -27. Because you are multiplying by the same number every time, that means that it's going to be an exponential function, which means that you're going to have some equation that's going to be a times b to the x. You're going to have the variable up here. They get a lot more complicated than this, but we're just kind of touching on it and not going to get too detailed about it. If they give you an equation, you can tell that it's an exponential function because the variable is in the exponent's position, which is right there. Okay, so if the variable's in the exponent's position, then we know it's an exponential function. All right, evaluating an exponential function, we're going to need a calculator on this, probably. It says an initial population of 20 rabbits triples every, be careful right here, half year. It's part of the formula. The function, so they're giving me a function, f of x really stands for y, but it's a function of x, where 20 times 3 to the x power is an equation that gives the population after half-year periods. So the question is, how many rabbits will there be in 3 years? Well, be careful, because we're talking about half years. So 3 years is equal to 6 half years. So that's what we're going to have to use for our time. We're going to substitute 20 times 3 to the 6th power, which is equal to 20 times, now we got to multiply 3 to the 6th power, which is 3 times 3 times 3 times 3 times 3 times 3. That comes out to, I hope I just did that right, because I'm using my little 4-function calculator. You multiply it out, it gives me 729. Let me do a quick check on that. I did 3 times 3 times 3 times 3 times 3. We've got 9, 9, 9. So really that's 81 times 9, 729. So that does work. Take your 729, multiply it by 20. And we end up with 14,580. So therefore, in 3 years, there will be 14,580 rabbits. So I don't know if you guys have ever heard of the expression that rabbits breed exponentially. So do cats and dogs, because they have litters of puppies and kittens and bunnies. But anytime you have where you have a rabbit has births to, say, 7 bunnies, and then those 7 bunnies grow up and they all have litters of 7 bunnies each, eventually what happens is that the population gets incredibly large very fast, and that's what they talk about when it grows exponentially. It's growing at a very fast rate. So let's look at this and see what it looks like, an exponential function looks like actually on a graph. So graphing an exponential function, let's go ahead and make a table. We're going to use this equation right here, y is equal to 3 times 2 to the x, and we're going to build a table. I'm just going to use my typical -2, -1, 0, 1, and 2. If you guys have graph paper, it will actually help, because exponential functions get tricky when you graph them because the numbers are not nice and neat. So we're going to substitute -2 in for x. We get 3 times 2 to the -2, which is 3 times 2 to the -2. You're going to have to flip that to 1 over 2 squared, which ends up being 3 over 4. You could think about it as 3/4 or 0.75, same thing. Let's go ahead and substitute -1 in. That would be 2 to the -1. So that's 3 times 2 to the -1 is 1 over 2. Got to flip to make your exponent from a negative to a positive, we end up with 3 over 2, which is 1.5, 1.5. Putting in 0, just substituting each of my domain into my equation to find my range. So we get 2 to the 0 power. Anything to the 0 power is 1, and 1 times 3 is 3. Let's go ahead and put in 1. That'd be 3 times 2 to the first. 2 to the first is 2, and 2 times 3 is 6. Please, at any time, put me on pause and try these by yourself. Don't always just copy what I'm doing. It's not going to help you as much. 2 times 2 is 4, and 4 times 3 is 12. So, let's see here. My graph goes up to 10. So if I graph these, negative 2 hits at 0.75. So negative 2 is right about there. This is a small graph, so it's hard to plot these points. Negative 1 is 1.5, right about there. 0, 3, 1, 6, 2, 12 is off my graph. You can see how it's curving, which we noticed back in the front. If I put in a negative 3 here, what would this be? I could keep doing this. That'd be 3 divided by 2 to the third, which is 3 over 8. Let's see, 2 to the third is 8. And changing that to a decimal, you'd have 3 divided by 3/8, which actually comes out to 0.375. So notice that it's actually getting closer to the x-axis. If I just kept going, put negative 4, negative 5, I don't care if I went all the way to negative 50, you're never going to hit the x-axis. So you're never going to come out to 0 in your y column. So this is going to be the hard part for me. Bit tricky for you, I'm sure, as well. But you've got to connect those points. When you come down here, you're going to want to keep going, but you don't want to go through the x-axis. It goes on forever, and this is actually an asymptote because it never touches the line y is equal to 0, or the x-axis as we call it. So, and don't forget also to label it, and that's the equation. So as you can see, as bunnies have bunnies, the population is getting bigger, but it's getting bigger at a very fast rate. It's going straight up. It's never going to be linear, but it's definitely going to start to look like it's heading directly up in the air. All right, guys, and that will do it.